ओके, मेरी आवाज आ रही है? और अगर आ रही है तो
Yes,
कैमरा
sir.
ऑन, कैमरा ऑन, कैमरा ऑन, कैमरा ऑन।
अस्सलाम वालेकुम।
वालेकुम सलाम। कैमरा ऑन करो सभी जल्दी से।
अस्सलाम वालेकुम।
वालेकुम सलाम। कैमरा ऑन। अटेंडेंस है। ओके, लास्ट टाइम हमने काफी कवर किया था रीज रिप्रेजेंटेशन थ्योरम के बाद, सो उसी को हम आगे बढ़ाएंगे। एक नजर में है, ठीक कर दो। तो रीज रिप्रेजेंटेशन थ्योरम बहुत ही इंपॉर्टेंट थ्योरम है हिल्बर्ट स्पेसेस में, कि यू कैन आइडेंटिफाई in a one-to-one manner a Hilbert space with its dual. And if you have a Hilbert space H, so for every, or you take its dual H star, for every F belonging to H star, there exists some Y belonging to H, a unique one, belonging to H, such that F of X is defined as inner product of X with Y for all X belonging to X, and of course norm of F is the same as norm of Y. This is if and only if. Of course, this is a bounded linear function. So what it becomes like is a situation like this: H is here, I've got H star is here. Then for every Y here, there's a one-to-one correspondence with some functional. I can call it F sub Y, just to kiska ek Y ke sath connection hai. So it preserves the norm and it also preserves the vector addition. Except for by that I mean, if I take two vectors here, Y and Z, and then add them, it would be mapped to the sum of the functionals F sub Y plus F sub Z. And of course, their norm is preserved and all that jo humne kiya. Uske, as a corollary to that, we showed that Hilbert spaces are always reflexive. Hilbert spaces are reflexive, and also as a corollary, you can define, H star is also a Hilbert space. If H is a Hilbert space, yani its operator norm comes from an inner product. It's also a Hilbert space. So ye kuch cheezein humne ki thi. Now we come to something called the Bolzano-Weierstrass theorem. So Bolzano, I should write Weierstrass property in this theorem to true hai. Before that, let's talk about weak convergence. So before doing that, we need a definition. Okay, as you know, हमने कहा था, if you have a normal linear space X, right? We say a sequence Xn contained inside this normal linear space X converges weakly. Xn converges to weakly, यहाँ हम WK लिखते थे, to X as n approaches infinity if X star at Xn converges to X star at X for all X belonging to X. तो इसमें हमने बहुत सारी बहस की थी इसमें या ऐसे भी लिखते थे कभी कि f of x n converges to f of x, वो यहाँ x star belongs to x star, sorry, for all f belonging to x star, ये भी सही है, as long as when you take the values of that sequence under a bounded linear scalar valued map, यानी linear functional on it, so जो sequence of scalars है, they preserve that convergence. यानी अगर हर एक functional के लिए that sequence of scalars converges to f of x, then we would say that xn converges weakly to x. So So अब यहाँ पे चूंकि you can actually identify, suppose now every inner product space is a normal linear space. तो ये सारा डिस्कशन तो उस पर भी अप्लाई आएगा है ना, H is also a normal linear space. लेकिन अब इसमें एक ही चीज है, ये जो X स्टार है या H स्टार है, it has an identification with H. और ये जो फंक्शनल है X star at Xn in the case of this thing या f of Xn जैसे भी तुम लिखना चाहो, by Ree's representation theorem, this is actually X and Y. Yeah, this is X and Y for some Y belonging to H. तो यहाँ पे थोड़ा सा obviously ये convert होगी, and instead of writing Xn at X star, we say Xn at Y. For some Y, unique Y belonging to the Hilbert space H. So let's write down the definition. उसके बाद उससे related हम कुछ चीजें करेंगे. Okay. So definition. Before doing those, otherwise trust. Yeah. Okay. Definition ये जो मैंने कहा, अब इसको थोड़ा words में लिखना है. So a sequence Xn inside H, where H is an inner product space, which is a normal linear space as well, is said to converge weakly to X belonging to H if Xn of Y as a sequence of scalars converges to XY for all Y belonging to H. क्योंकि यहाँ वो है ना, मतलब change हुआ है, because a functional can be written in this manner. So that's, and we write, हम इसको लिखते हैं फिर, जब ऐसा हो तो we write Xn converges, ऊपर लिखते हैं weakly to X. So that was weak convergence. इससे रिलेटेड एक थ्योरम करेंगे, जैसे कि तुम्हें पता है norm convergence implies weak convergence, but weak convergence does not imply norm convergence. Same is true, but here we can make a little progress, but because of inner product. क्या? In a Hilbert space H, Xn converges strongly to X in a norm if and only if norm of Xn converges to norm of X and Xn converges weakly to X. देखो मतलब अगर weakly does not, मतलब ये तो ये इसको imply करता है automatically और ये इसको भी imply करता है automatically, इन दोनों convergences को. This is the convergence of norms, convergence of numbers. So लेकिन ये जो है तो weak convergence need not imply convergence. लेकिन अगर हम उसके साथ add कर दें ये convergence of the norms, मतलब जब norm लगा दें उनको, then it would imply the strong convergence, the normal convergence. Proof is easy, you just have to use the definition. Now suppose Xn converges to X, it just implies that norm of Xn minus X जो है, now that is the meaning of strong convergence or norm convergence. ये है उसका जो मैंने लिखा है इस line में. So now if I look at this inner product Xn minus X with any Y, this is by Cauchy-Schwarz inequality, less than equal to norm of Xn minus X into norm of Y, which goes to 0 for all Y belonging to Y, H. So what does that mean? That means, of course, that ये 0 में हो रहा है, तो it means ये अंदर का 0 हो जाना चाहिए, because norm is a continuous function. It means that limit n approaches infinity. Yes, x and minus x y is equal to 0, which using the properties of the inner product means that limit n approaches infinity, x and y is equal to xy. So all y belonging to h, which would of course imply that xn converges weakly to x. तो norm convergence implies weak convergence, जैसे वहां था वैसा यहाँ था, ठीक है ना? Of course ये भी automatically also ये तो है ही कि norm of xn minus norm of x in mod is less than equal to, this is just a triangle inequality, norm of xn minus x, so this goes to 0, implies that norm of xn converges to norm of x. दोनों चीजें एक साइड ऑब्वियस, अब दूसरा थोड़ा एक्चुअली हमें प्रूव करना है. ये conversely suppose that xn converges weakly to x and norm of xn converges to norm of x as n approaches infinity. So now we observe that norm of xn minus x square, it can be written as we know, xn inner product xn minus x, xn minus x. Now what you do, you just expand this inner product, so this would be xn minus xn x minus xxn plus, it should be xx. Now that is equal to, let me write, this is norm of xn square, then इसको मैं यहाँ से लाऊंगा तो बन जाएगा plus norm of x square. That's the definition of the norm in a product space. Then I have minus xn x minus, I can write xn comma x bar. You know, these are just properties of the inner product. Now this would converge to, look at this. This would converge to, क्योंकि मैं assume कर चुका हूँ कि xn converges weakly to x. It means xn x जो है वो converge करेगा to, you know, जब मैं कह रहा हूँ weakly, उसका मतलब जो है ना, मैं कह रहा हूँ xn y converges to xn, sorry, जब मैं कह रहा हूँ xn converges weakly to x, it implies that no, क्या मैं कह रहा हूँ, xn y converges to xn, नहीं sorry, x comma y for all y belonging to x. It also means then, अगर मैं लूँ norm of x, inner product x with x, this must converge to, क्योंकि for all y belonging to h है, तो this should converge to x equal to norm x square. मैं वही use यहाँ करना चाहता हूँ. This would converge because norm xn converges to norm of x, so this should be norm of x square plus norm of x square. And of course ये भी converge करेगा minus norm of x square, और ये भी converge करेगा norm of x square, right? Because it's a non-negative number, conjugation से कोई फर्क पड़ेगा. So that's equal to 0. So therefore xn converges to x strongly as n approaches infinity. और ज्यादा कुछ है नहीं किसी. तो अब ये थोड़ा weak convergence से related एक छोटा सा result है. Now let's come to, you know, Bolzano-Weierstrass theorem पता है किसी को? For real numbers. Every, मतलब Bolzano-Weierstrass theorem जो है real numbers में every bounded set of real numbers, है ना?
has at least a limit point.
बिल्कुल. Real numbers has at least one limit point. But this is equivalent to saying that every bounded sequence of real numbers has a convergent subsequence, because limit point would be the limit of a subsequence. So every bounded sequence is a convergent subsequence. That can also be the statement of the Bolzano-Weierstrass theorem. But this is not true in general for a Hilbert space or an n-product space. For example, L2, agar मैं लूँ sequence E1, E2, so on and so forth. And this is a bounded sequence. Why? Because En से मेरी मुराद है the sequence 0, 0, so on and so forth, 0, 1, 0, so on and so forth. अगर En ये है कि उसके यहाँ 1th place है, अब L2 में देखो En जो है उसका नाम तो फिर 1 आएगा हमेशा इस L2 space. So it is a bounded sequence, but it has no convergent subsequence, because अगर तुम लोगे En minus Em, that would be जैसे कि हम इससे पहले कर चुके हैं √2 for all n not equal to m. So इसका मतलब it has no even a Cauchy subsequence भी इसमें कोई नहीं हो सकती. Convergent होने का तो सवाल ही नहीं, क्योंकि इनके any two different जो elements होंगे इस sequence के उसके दरमियान जो distance है वो कम नहीं हो रही है, fixed. So in general, as you can see, the Bolzano-Weierstrass theorem does not hold for normal linear spaces or Hilbert spaces. But there is a theorem which holds, जिसको हम कहते हैं Bolzano-Weierstrass property. तो अगर हम instead of taking this, we can show that every bounded sequence has a weakly convergent subsequence, not a convergent subsequence, but a weakly convergent subsequence. That is true, that converges weakly. So that's what is the Bolzano-Weierstrass property for Hilbert spaces. Actually, this is true for reflexive spaces also, because every Hilbert space is a reflexive space. लेकिन यहाँ पर क्योंकि हम inner product spaces कर रहे हैं, तो we will show it for Hilbert spaces. Now, Bolzano-Weierstrass property for Hilbert spaces. Okay. So इसकी जो statement है as a theorem हम उसको लिखेंगे जैसे कि मैंने कहा every bounded sequence in a Hilbert space, every bounded sequence in a Hilbert space contains a weakly convergent subsequence. Contains a weakly convergent subsequence. So proof शुरू करते हैं. We take a bounded sequence. So let xn be a weakly bounded sequence. Be a bounded sequence. Bounded sequence in the Hilbert space H. Okay, so what I do, the bounded sequence का मतलब क्या हुआ? A bounded sequence means that you have got there exists some m positive, so that this is less than equal to m for all n greater than equal to 1. That's what we mean by bounded sequence, that each of its vectors is less than equal to its norm, it's less than equal to some positive number. So that's, now this is my bounded sequence. So it implies that it is weakly bounded. because every bounded sequence is weakly bounded in any normal linear space. तो I say that वैसे वो सीधा ही prove भी कर सकते हैं. So xn, चलो मैं ऐसे लिखता हूँ, ऐसे मैं लिख सकता हूँ, xn is a bounded sequence of scalars. Why? Because we know that xn, x is less than equal to norm xn into norm of x, so which is less than equal to m times norm of x. So if I fix x for a fixed x and let n range, so this is a sequence of scalars, complex numbers, that's bounded. So hence by Bolzano-Weierstrass theorem, या पहले मैं इसको लिखता हूँ, it implies that I can see that अगर मैं लूँ xn और फिर इसका खुद ही कोई वेक्टर लूँ, fixed one, x1 लूँ, x2 लूँ, x3 लूँ, and I let n run from 1 to infinity, is a bounded sequence of scalars for all k greater than equal to 1. मतलब इसको fix करो, it would be a bounded sequence of scalars, and therefore should I write it like this? Okay, and therefore सीधी लिखता हूँ, by Bolzano-Weierstrass theorem for scalars, actually of course it's also complex numbers if they are bounded, then of course by the real theorem for Bolzano-Weierstrass theorem you can get the complex version also. If you have a bounded sequence of complex numbers, then of course it would have a convergent subsequence. That's not straightforward. चलो वो तुम कर सकते हो as a home assignment. Anyway, therefore by Bolzano-Weierstrass theorem, has a convergent subsequence. This set of scalars. Okay. Now denote by ऐसे में लिखूंगा x n comma 1 x1 n runs from 1 to infinity, the a convergent subsequence of x n x1. Now मैंने बोला हर किसी का, यहाँ पे कुछ भी मैं डाल सकता हूँ, suppose मैं x1 डाल दिया, so this is a bounded sequence of scalars because of this relation. So क्योंकि x1 fixed है, so it has a convergent subsequence. I denote it by this symbol. ये इसकी एक subsequence है, means जो xn1 ये तो fixed है, तो subsequence कौन होगी? यानी xn1 को मैंने माना a subsequence of xn, इसको मैंने नाम दिया xn1. xn1 is the subsequence of xn such that this is convergent. This sequence of scalars is convergent. Okay, so I can go on and on. Now what I do, now I have found xn1 मैंने नाम दिया xn comma 1 जो है n runs from 1 to infinity is a subsequence of xn. So remember that. Now what I do, मैं इस sequence को लेता हूँ जो कि एक subsequence है, and I know that xn1 x1 is convergent. ठीक है ना? What I do, अब मैं इसको लेता हूँ और अगर मैं by the above argument जो मैं लिखूंगा, by the above argument, if I take this subsequence and take its inner product and 1, इनर प्रोडक्ट xn, 1 x2 जो है is a bounded sequence of scalars. Why scalars? चलो, because by Cauchy-Schwarz inequality xn, 1 x1 is less than equal to norm of xn1 into norm of x, चलो x2 सॉरी यहाँ मैं लिखा, ठीक है। अब x2 फिक्स्ड है, लेकिन ये जो है ये इसकी सब सीक्वेंस है ना, सो दिस इज आल्सो लेस देन इक्वल टू m, क्योंकि सारे के सारे xn जो है लेस देन इक्वल टू m है, so into norm of x2, so of course this is a bounded sequence of scalars, it's less than equal to some positive number. So now this is a therefore it has a convergent subsequence इसको मैं नाम दूंगा xn2 to x2। तो तुम्हें ध्यान रखना है, I had a sequence xn, उससे मैंने निकाली एक सब सीक्वेंस xn1, उससे मैंने एक सब सीक्वेंस निकाली xn, 2, ठीक है ना, इसकी एक सब सीक्वेंस है, यानी इसका सबसेट है और प्रिजर्व करता है ऑर्डर को, दैट्स व्हाट वी मीन बाय सब सीक्वेंस, सच दैट xn1 जो x1 जो है वो कन्वर्जेंट है, इसी तरह से नहीं, मैं गलत लिख रहा हूँ, xn1 ठीक है, हाँ इट्स कन्वर्जेंट सीक्वेंस, ठीक है, एंड इसी तरह से यहाँ जिस हिसाब से मैंने इसको लिया है xn2, x2 भी कन्वर्जेंट है, इसी तरह से so on and so forth, right? ठीक है ना, ओके, तो ये अगर तुम दिमाग में ठीक से बिठा लो और इसको बाद में फिर से देख लो तो इट वुड बी, एंड वी गो ऑन एंड ऑन। अब मैं इस xn को x3 से लूंगा, राइट, तो दैट वुड आल्सो बी अ बाउंडेड सीक्वेंस, देन आई टेक अ कन्वर्जेंट सबसीक्वेंस, इसका नाम मैं रखूंगा xn3 x3। So proceeding similarly, similarly यही करते करते for each k greater than equal to 1 we get a convergent sequence, ऐसे मैं लिखूंगा xn, k xk, right, which is a subsequence of xn k minus 1 xk. I think yes, that's how we write it. Of course यहाँ n run कर रहा है, okay, we claim that अगर मैं लूंगा ये सीक्वेंस xn, n is weakly convergent, मुझे चाहिए ना एक सब सीक्वेंस ऑफ xn जो ओरिजिनल सीक्वेंस है, that's weakly convergent in H. So we claim that this is weakly convergent in H. So अब तुम्हें ध्यान में रखना है, मैं फिर से लिखूंगा, I've got a sequence x1, x2, so on and so forth, right? इससे मैंने एक सब सीक्वेंस निकाली xn1, xn2, ठीक है ना, how do I write it? xn1 एक सीक्वेंस है ऐसी जो इसकी सब सीक्वेंस है, फिर एक सब सीक्वेंस है xn2 जो इसकी सब सीक्वेंस है, राइट? So if I want to arrange them, चलो पहली सीक्वेंस ऐसी थी x11, x1, x21, इसी तरह से x31, so on and so forth, फिर उसकी एक सब सीक्वेंस है x12, x22, what do I have? x32, so on and so forth, फिर इसकी एक सब सीक्वेंस, ये जो हम हर स्टेज पे एक सब सीक्वेंस निकाल रहे हैं, तो इसी तरह से होगा x13, x23, x33, so इसी तरह से I've got a subsequence, मतलब this is a subsequence of this is a subsequence of original sequence, तो अब मैं ये ले रहा हूं इसका डायगोनल, मतलब x11 x22 x33, ऑफ कोर्स ये सारी की सारी xn की सब सीक्वेंस है, और मैं कह रहा हूं ये जो ये सब सीक्वेंस, सो दैट वुड बी कन्वर्जेंट वीकली कन्वर्जेंट सब सीक्वेंस। तो उसके लिए मुझे क्या दिखाना है, तो अगर मुझे दिखाना है वीकली कन्वर्ज करती है, तो आई बेसिकली हैव टू शो दैट if I want to show that x and n converges to n comma n converges to some x belonging to h weakly, I have to show that x n n y converges to xy for all y belonging to h. So ये जरा तुम देखो, ठीक है। पहले हम दिखाएंगे ये कन्वर्ज करेगी, देन फिर दिखाएंगे एक्चुअली ये किसी वेक्टर को कन्वर्ज करेंगे इन दिस मैनर। तो उसके लिए so let x belong to h। अब चूंकि ऑफ कोर्स इसमें एक xn जो मैंने सबसीक्वेंस ली है that also lives inside h। so अगर इनमें से कोई है, suppose x is equal to some xm, मतलब इसका कोई टर्म, कोई भी टर्म, then we know that x n n n comma xm n runs from 1 to infinity is a subsequence of I should write x nm xm, right? क्योंकि मैंने अब इसको रेस्ट्रिक्ट किया ना, ये जो n के वेक्टर्स हैं, nm था, अब nm मैंने कर दिया, right? So it has a subsequence which, okay, which is a subsequence मैंने क्या दिया, just a minute. Okay, I wrote that is a subsequence of, just a minute मैं जरा ये ड्रॉप करूंगा इस तरह से, is a subsequence of a convergent sequence, ऐसे मैं लिखूंगा x n m x m for m less than n, ठीक है। I think so this should be okay। जो हमने इस तरह से अभी लिखा था ना, यहाँ क्या था, अगर ना मैं ये इसकी सबसीक्वेंस है, ये इसकी सबसीक्वेंस है, तो ये जो बड़ा वाला है वो छोटे की सबसीक्वेंस है ना, इन दिस मैनर। सो ईच ऑफ देम, जब मैं इसको इसके बराबर रखूं, यानी दिस इज ए कन्वर्जेंट सीक्वेंस व्हिच इज अ सबसीक्वेंस ऑफ दिस थिंग, यानी ये इससे कम है, तो इसी तरह से वो पहले वाले से कम है। तो अगर ऐसा है, मतलब थोड़ा सा अगर तुम घर पे थोड़ा रफ गंदा करोगे, तो यू विल सी दैट दिस इज अ सबसीक्वेंस ऑफ दिस सीक्वेंस। अगर m लेस देन n है, तो then this is a convergent sequence. So a subsequence of a convergent sequence would be convergent and hence convergent. तो मैं जरा फिर से इसको, so I've got x and m, तो मैं m को फिक्स कर रहा हूँ, यानी दूसरे वाले को, इसको जब फिक्स करेंगे तो you will get a column of sorts, so with xm। तो यहाँ तक है ये सीक्वेंस का आइडिया है, बट जहां तक ये सीक्वेंस ऑफ स्केलर्स का ताल्लुक है, then this would be a subsequence of this thing, fine, क्योंकि यहाँ n के सभी पॉसिबल वैल्यूज हैं, मैं यहाँ ले रहा हूँ m is less than n, यानी कम वैल्यूज तो इसके हैं। so but this is indeed, अगर m less than n रखा जाए, now this is a convergent subsequence and hence convergent, ठीक है। so therefore using the properties of the inner product, तो अगर x h में था और सीक्वेंस की कोई टर्म है, तो ये कन्वर्जेंट है। so it implies that by the properties of the inner product x n n comma x comma है n के बीच में, is also converges if x belongs to the linear span of this sequence। if x belongs to the linear span of these xn's, n runs from 1 to infinity. So obviously because of the properties of the inner product अगर ये converge करेगा for 1 तो उसके linear combination के लिए you will get a sequence of scalars that are all convergent whose sum is xn and x. So since each of the terms in the scalar of sum each term in the sum would converge, so therefore this must converge. वो तो मतलब straightforward नहीं लगता इसका, इतना difficult है. Now ये next step है हमारा. Now let x belong to M. तो मैं closure लेता हूँ इस span का. I take the span of xn, n runs from 1 to infinity, इसका closure. तो closure का मतलब ये है, then there exists a sequence xm, x नहीं लिखना चाहिए, x और भी हम दे चुके हैं. Let's call it ym. M runs from 1 to infinity. Inside the set under the closure, that is span of x and n runs from 1 to infinity, such that ym goes to x as m approaches infinity. So that would mean, अब हम use करेंगे again the properties of the inner product. But if I want to take the inner product of x and n with x minus ym, this would be less than equal to norm of x and n ym minus x. So that means, what does that mean? Now this is less than equal to some m नहीं लिखना चाहिए, कुछ number है ना, because this is a bounded subsequence of a bounded sequence originally. So इसको ऐसे ही रखते हैं. This is less than equal to some number, and this goes to 0 as m approaches infinity. Hence I can say this, and I say x and n जो है, right, where is it? About this thing goes to 0 as n approaches infinity. That means what? अगर मैं इसका मतलब ये हुआ, this goes to 0 means x and n comma x is equal to, चलो मैं ऐसे लिखता हूँ, this must converge to using the properties of the inner product to x and n comma ym, and since this converges weakly, so therefore this must converge weakly. So if this converges to this, what does that mean? And I'm sure this converges weakly. Just a minute. So I have to show that xn and x converges to weakly. So you have, this must goes to this as m approaches infinity. So I have now, या तो ऐसे हम लिखें या फिर कुछ और करें. हाँ ऐसे भी लिख सकते हैं, चलो मैं यहाँ लिख सकता हूँ. Limit m approaches infinity x and n. हाँ ठीक है, अगर इसको ऐसे लिखेंगे, चलो लिख देते हैं. Limit m approaches infinity xn and ym is equal to xn comma n x. So this is, since x by previous जो हमने किया था is weakly